Hello, Goldmash. How you doing? Doing good. How are you? Go to the switch over here. Alrighty. Hello, hello, hello. How are we doing today? Hopefully we're doing well. At least I hope we're doing well. Alright. Good morning, everybody. Good morning. Just chilling before Thursday? Alright. Is there anything special going on Thursday? Anything special on Thursday there, Goldmash? I don't know if there is, but maybe you got a game coming up or something? Okay. Boatload of emojis, question mark. Are you going to Glasgow on Thursday? Alright. What are you and your family gonna do? Are you just are you shopping around Glasgow, or are you gonna take a tour? What's the story? See relatives? I don't know. What's going on in Glasgow? I heard Glasgow's a really nice city, so. Let's see here. It sounds like you're excited. Watch Scotland v Israel on Saturday at Hampden. Alright, very cool, very cool. That should be a pretty fun match. That should be a pretty fun match. I hope you have a lot of fun watching that match. Hey, Beast, how we doing, my friend? We doing good? How you doing this, well, my morning, maybe your afternoon? You good? Good, my friend, good. I'm doing okay. I'm doing pretty good actually. I woke up not too long ago and still feel a little bit tired. Yeah, I know it's in the evening for you over there. Here it's like 11 o'clock in the morning. 790. It's okay. I don't do this channel for the followers. I just do it for the I do it for the math memes. That's what I do it for. Wait, you missed school yesterday. Well, that's kind of a bummer. You feeling okay, Beast? Oh no, that sucks, yo. Did you accidentally hurt your back there, Beast? Is your back back to normal? I had to get pulled out of my bed. Hey, Sneaky Weasel, I had to get pulled out of my bed by my brother. Oh, ooh, that hurts. How we doing today, Sneaky Weasel? How we doing today? Hopefully you're here for another rip-roaring day of statistics. At least I hope so, question mark. It could have just, Beast, it could have just spasmed. You could have just slept on it the wrong way and it could have frozen place. Your brother left for university yesterday. Oh. Well, I'm sure that you hurt your back Thursday as well. Slipped down the stairs. So I was gonna die because oh my gosh, it's terrible. Well, if he didn't get you a biscuit there, Glomashko, think it's okay. You'll just go get one from your dad. You went to England with my dad. Now I'm going to England for a holiday in 2 weeks. Very good. So if your brother's going to what university is your brother going to? In England? Beast? Yeah, I hate when that happens, man. Sheffield? Okay, wonderful. Does he have a area of study he would like this? Is there an area of study he wants to work into? Bob. Your back wasn't good. Your back is good now. Oh. Well, it sucks to let's be honest here, ladies and gentlemen. slipping Accidentally slipping and hitting your back on the edge of the stairs is never the most comfortable times ever. Okay? If it's just it's a little less uncomfortable, so he wants to do dentistry, but UK's rules essentially screw him over, even though he got a 3-star in level. Oh. Well, I don't know about the rules in the UK or anything like that. But I hope you'll be able to do something with dentistry. No, it's okay, Beast. I understand it would make you feel frustrated because the rules are basically kind of screwing him over. But if he does dentistry over in the UK, hopefully hopefully he can be a dentist, and he could do dentistry over here as well in the United States. We have a lot of dental colleges. In fact, how would I say this? Like the place that I work at for. Now I know you grew up in the UK, so for example, the place that I work for has a dental assistance school. Um, so those of basically we have like a whole dentist office, like chairs and everything, with volunteers and the whole 9 yards there, Beast. And we have people who are studying to be dental assistants and whatnot are learning with practical experience. So they come to my community college, and they get practice in working on real people, while dentists come over and help them and are instructed at the same time. It's actually a pretty nice system. I know that's not the same as being a dentist. Obviously, there's a big difference between the two, but I find it to be pretty cool that we can train people to be like dental assistants as well. And the best part is it offers a nice place for our community to get free dental work. So That's one of the nicest things about that. That's pretty cool. He prefers the UK over any place, even though my uncle lives in the US, I guess. Your girlfriend says, "Hey, hello, Beast's girlfriend." Ask her how she's doing today. I hope she's doing fantastic. I'm starting to wake up a little bit. The energy's starting to come back a little bit. Starting to feel the effervescence of life coming through my veins with a slight bit of tinge of caffeination. She's absolutely spiffin' excelente. That sounds like absolute brilliance right there. I'm glad she's doing well. It's like you watching WWE? There you go. No, today look, Sneaky. I got some matcha, some green tea plus some milk, my man. So, I do. So, green tea is so good. It's true. I was just listening to the greatest rock and roll singer of all time. Can you guess who it is? I don't know. There's a lot of rock and roll singers. You could say like, you can run up and down the gamut. There's like I don't know. You could say like Van Halen's was a really good rock singer, 100%. Very good rock and roll singer. Freddie Mercury. There you go. Everybody thinks I'm weird because I drink almost every hot drink. I don't think that's weird. Look, I like to sometimes in some areas I like to drink are you talking well there's wait Sir Paul McCartney? Sir Elton John? I mean, it's a type of royalty if you put a sir in front of it. You say cool. Hot drinks are great. Lattes, cappuccinos. Yeah, I like hot drinks. Look, one of the things I really like, like when I was in Japan, having hot drinks, like you could get it from the vending machine. You could get hot drinks. So like, for example, you could get like a hot drink of like corn soup in a can. It was pretty good for those cold winter days, let me tell you. Absolutely outstanding. Corn potage soup in a can. Pakistani tea as well. There's like 8,000. Yeah, there's like 8,000 of them. There's no question about that. Hot chocolate. Hot chocolate's outstanding. I love hot chocolate. I like me my hot chocolate. But you gotta try other types, you know. Earl Grey tea. Hot matcha tea is actually absolutely outstanding. Alright? I mean, Kashmiri chai, holy crap, dude. Kashmiri chai should be like... Kashmiri chai should be like labeled as a drug. Like, that stuff is super addictive and super good. Ooh, Kashmiri chai. Ooh. Oh. Oat milk is the bomb. Yes, oat milk is absolutely outstanding. I like oat milk. Some nice hot oat milk. I agree. My go-to hot drink is a double tall oat milk latte. You know what, Sneaky? I can get down with that. I can get down with that. You know, I once went. All right, true story. I once went to a wedding where they had Kashmiri chai at the wedding. It's the only wedding in history I've ever seen where somebody brought in Kashmiri chai for a wedding. And oh my goodness, I was like, this is the best wedding I've ever been to in my life. Well, okay, it still is the best wedding I've ever been to in my life. I don't look at tea, and I don't like coffee because it's too expensive. Well, trust me. Let me tell you something, Goldmash. The older you're gonna get, the more you start to appreciate tea and coffee, especially waking up in the morning. Right now, it may not make any sense, but trust me, you get to appreciate it more and more. I totally understand where you're at right now. That's how I was back in the day, but I came to appreciate it a whole lot more the older I got. Coffee best more expensive, said yeah, that's true. It does. You can come to my wedding? You betcha, buddy. I'm down for that. I'm down for that. If you're willing to invite me, I'll be happy to come. What's my favorite kind of tea? My favorite kind of tea is milk tea. Give me some Pakistani chai, or some some royal milk tea. That's where it's at, man. I work at Starbucks. I love the taste rather than the feel it gives me. That's fair. That's fair. Milk tea, amazing. My mom doesn't like tea or coffee, so I must get it from her. That's fine. Some people, that's okay. You don't have to like tea or coffee, but I tell you, once you get started, ladies and gentlemen, with tea and coffee, I think you all know where it goes. You get started with tea and coffee. There you go. I'm inviting Professor Chips to my wedding so we can debate philosophy while eating our meals to give my girlfriend a headache. But wait a second here. If I'm going to your wedding, your girlfriend will be your wife at that point in time. And we're gonna have to debate about what her designation will be by the time the wedding comes around. Not liking tea is at 50% Pakistani. Like, yes, it's true. Absolutely 100%. Good morning, Jasmine. How we doing? Iced chai. There you go. Iced chai. Iced chai, man. Pakistani will have 8 million cups of tea every day. Absolutely true. Absolutely true. 100%. And if you guys don't know what Kashmiri tea is, the Kashmiri chai. I'll show you guys Kashmiri chai if I haven't shown this. I've shown this on the channel before, but maybe not to you guys. So I go to the main screen here. I go to the big screen. Have a good one, Golbash. So that's Kashmiri chai, guys. That's Kashmiri chai. Those of you who had it, you guys have seen this before. Shouldn't be anything brand new. But Kashmiri chai is the absolute most amazing, addictive chai you could ever have. It's so good. I'd be more than happy to be that. Not a problem, Victoria. If it means I get to drink it every day. Kashmiri chai. Yes, 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 yes. Yes, indeed. Oh. That is a tougher story. It's tough to actually find it actually made legit. So, let me see. I thought that there may be one place. Could be wrong. Yeah, there was this place. That's right. And I've only been here like once. And I believe this place was across the street from somewhere that I know. I believe. Yeah, so there's this place here. I'll put it up on I'll put it here on the screen. Let me check if they actually have that here. Menu, please. I don't care about all your wraps. Ah, yes. They have Kashmiri chai for $2. Alright. One can hope. Here you go, I'll put it up on the screen here. So it's in Glendale Heights. Yeah, homemade Kashmiri chai is the best, but you know as much as I do. It takes a long time to make. It takes quite a bit of time to make. But there you go. There's a place in Glendale Heights that you could go to. It's $2. It does look. Quality takes time. You know that, Beast, better than I. All right, you know it takes time, but I'm not gonna complain. And don't get me wrong, I love me my Earl Grey tea, by the way. So, love me Kashmiri chai, but of course a nice Earl Grey can never go bad. Best of King Sweets in Devon. Fair. I don't know what Tahura has it. Anyway. Yeah. There's Tahura. There's Tahura in Devon, right? So, they got all the sweets all the time. There you go. That's what I'm talking about. Anyway. Alright, ladies and gentlemen. I gotta do a class. That's amazing, but I have to do a class. As much as I would love to continue to talk about stuff on Devon there. Boba tea is legit. Alright, I like boba tea. I know some people don't like the tapioca stuff. But you know what? Boba tea, pretty good. Okay. Look, you gotta give every tea a try. It's they're all very good. Pop and boba, yeah. I'm down with that. I'm down with that. Let's see, see if I can find corn potage soup in a can. So they have, like, this is corn potage soup. Now, you can buy this type of soup in a can in Japan. So, at a vending machine. This I do know for a fact. It's like consomme soup or corn potage soup. It's actually pretty good. Make one stream for only talking, I know. I could go on for hours in all honesty. But this stream was made for mathematics. When he goes for business, she's brilliant. All right, ladies and gentlemen, let's. All right, we gotta do this. Let's do this, ladies and gentlemen. Let's do some intros here, and let's get moving. Okay. All right, I actually gotta do, you know, the thing that I somehow get paid for. Question mark. Question mark. Question mark. Okay, so let's do this. Okay, let's get started today. Welcome back. Welcome back to Tuesday. Hopefully, have a nice weekend. All right, so for today, we've been talking about teas and stuff. Hopefully, everybody is now here, and here. All right, so for today, ladies and gentlemen, we are going to be going into a new chapter here. Okay, so let's talk about a brand new chapter here. We're going to be doing chapter 6. Last time we did a review here for chapter 5. Now we're getting right into chapter 6. Now, chapter 6, just to let you know, is halfway through the textbook. So we're on good pace already to get things done. All right. When he goes to business in Japan, yeah. All right, so let's talk about today. We're going to be talking more about probability. We'll be expanding upon the topic of probability. We looked at probability all of last chapter, looking at different scenarios here. Now, today we're going to be looking at least in this first section, talking about probability distributions, okay? And putting it in terms of a context of things that we talked about earlier. So, let's go ahead and take a look here so we're going to talk about discrete and continuous random variables. We'll compute and interpret the mean of a discrete random variable and the standard deviation as well. So we're using a little bit of the calculator here. Not too much, but pretty simple stuff. All right. In any case, let's look at number 1. What is a random variable? All right, so a random variable here in the world of probabilities is a numerical measure of the outcome of a probability experiment, so its value is determined by chance. So we label it as the notation here as capital X, or again, any letter here. Capital X happens to be the most common one, but you can put it as letter A, letter B, letter C, whatever you want. So an example here would be like the probability of rolling 1 on our 6-sided die. That would be a random variable, because that is a possible outcome that can happen when we conduct our probability experiment. Okay, and we could designate that as a letter if we want to. Again, just like we could designate it as an event, same dealio. Now, what we want to do here is, specifically in these random variables, is basically, we basically say, okay, well, this is a possible outcome that can happen if we roll a six-sided die or whatever our probability experiment is going to be. And then we associate a probability that goes with that. So what exactly does it look like? Well, just to highlight what that looks like here in a very simple sense. Let's go, I'm just going to showcase the book here. So it'll look something akin to something like this. Okay, so for example, in this question here, you talk about, say, the number of televisions, right? And then the probability of selecting X amount of, let's say, TVs in this probability experiment. Here's the probability off to the side. So this is like what we call a probability distribution. This first half here, this X number of televisions, would be your random variable, your possibilities for selecting. In this case, the context in this is like the number of TVs. Fine. All right. That's essentially what I'm talking about here in this instance. Now, having said that, let's take a look here at numbers 2 and 3. We'll talk about these very briefly and then move forward. So, what is a discrete random variable? A discrete random variable is a random variable that has a finite or countable number of values. So just like we talked about way back in chapter 1. All right, we talked about discrete variables. Again, they have a finite or countable number of values. So again, that's going to be a discrete random variable. What's a continuous random variable? A random variable is infinite number of values. Again, same deal as what we talked about back in chapter 1. A random, again, infinite number of values. You can put literally any value you want. And again, that's going to be a continuous random variable. Okay. So again, if we go back to our book example here, the number of TVs would be a discrete random variable because we could only have a set amount of values. You could have 1 TV, 2 TVs, 3 TVs, 4 TVs, whatever you want. Okay. So if this could take on any infinite amount of values here, well then I could have, say, 9.37 TVs. Obviously it doesn't make any sense in the context of this problem, but that would be like a continuous variable if we were allowed to do that. Okay. Now, go back to here. Let's go on to number 4. All right, let's talk about number 4, and then we'll talk about number 5, and then we'll do some examples. All right, number 4. What is a probability distribution? A probability distribution, basically a distribution that represents the possible values of random variables and their corresponding probabilities. So just as I showed before, let's go split screen here for just a moment. So as you can see here, this table that we just talked about before is a probability distribution, okay? So again, it has all the random variables here, all the possibilities, all right? And then all the probabilities associated with those possibilities, okay? Oh, sorry, I'm going a little too fast there. Apologies, both of you. No, you're not allowed to write things down, okay? All you can do is take selfies with my handiwork in the background, okay? That's all you're allowed to do in my class. You'd be like, this looks fantastic. No problem. Sorry for going a little too fast. Apologies about that. No worries, guys. Okay. Now, let's take a look at this here. Now, we have a distribution that represents the possible values of random variables. Again, just like this table we see here for number 17. Now, there are 2 properties that we have to follow, and these 2 properties are things that we've talked about before, okay? And these should be anything brand new. Number 1, the sum of all the probabilities put together have to equal 100%, so it has to equal 1. So we add up all the probabilities, and if they equal 1, perfect. That's exactly a good distribution, okay? A good probability distribution, that is. And the second one here is that all probabilities here must be between 0 and 1. So we can't have probabilities that are negative. We can't have probabilities that are larger than 1. So that is right out. If we see a probability that's negative, no, that's not a probability distribution. Makes no sense to have something have negative odds. Makes no sense at all. Okay, so take a good look here at the right for just a moment. Okay, let's take a good look here at the right-hand side here. Now, we're going to look at these, if you see these block of problems here at the very bottom, 9 through 14. Let's take a good look here. Okay, so simple yeses or nos coming from you guys. Very simple yeses or nos. Let's look at number 9. Is number 9 a probability distribution, yes or no? Is number 9 a probability distribution, yes or no? Yes? Okay, good. The answer definitely is yes, okay? You add up the probabilities, they equal 1. Okay, whatever this probability experiment is, we don't know, but it doesn't matter. Okay, context doesn't really matter here. We're just saying, hey, is it yes, or is it not? No. Fine. All right, fair. All right, let's look at number 10. Number 10, yes or no, is that a probability experiment? A probability distribution, sorry. My bad. All right, Alex says yes. What do you guys think? No? Don't forget to add up your probabilities here. If we add up these probabilities here, does it equal 1? All right, yes, right? Okay. Joseph says yes. All right. So the answer for number 10 is yes. Okay. If you add up these probabilities here together, they indeed will equal 1, which is exactly what we're after here. And they don't violate the second rule here. All of them are between 0 and 1. Fair enough. How about number 11? Yes or no? Probability distribution. Okay. That is correct. All right, that is correct. The answer is no. You can't have a negative probability. That's a no-go. All right. How about number 12? Yes or no? Nice. Okay, the answer is yes. Absolutely is. Okay. Again, even if you have, it still equals 1. You may have probability of everything else being 0 except for that last one, but it still counts. That's fine. 0 and 1 can be included in our probabilities, so no problem. Number 12 is a yes. How about 13? 13, yes or no? All right, 13 is definitely a no. If you add up the probabilities here together, you will get something that is less than 1 here in this instance. I think you get 0.95 here in this instance. So, unfortunately for us, adding up the probabilities doesn't equal 1, so therefore 13 is a no. How about 14? 14, yes or no? Last one here. 14, yes or no? Okay. And that's fair to say. All right, the answer definitely is, you're right. The answer is definitely no. All right, for the same reason as we had for the last problem. We add up the probabilities. It's going to be more than 1 in that instance. And again, too bad, so sad for us. All right, seems fair. So pretty easy to tell, again, once we have those two properties, put them together, Easy peasy lemon squeezy. All right, no problem. All right. Now, we have that. That's great. And we'll be working more with this in just a second. Now, we're also going to introduce one other thing here with, we're also going to introduce one other thing here, and then I'll also talk about standard deviation. I'll talk about that. But the next thing I want to talk about here with probability distributions in relation to that is talking about finding the mean / expected value of a discrete random variable. So within these probability distributions, what we want to talk about is we want to talk about what's called the expected value. Now, the expected value is also the mean of this probability distribution. The big difference is in that in this case, we're automatically given the probability straight up, and we're just given these results here straight up. So, how do we find this mean / expected value? Well, first and foremost, what I've put up here on the screen, on the handout at the very least, I'll come back to the book here for just a second. But I put in the notation here, first and foremost. That's going to be either this mu of x or this capital E of x. Okay, so this is the notation here for expected value or mean in this case. And this is equal to the sum of all the random variable times its respective probability. So we take the random variable, multiply it by its respective probability, and then add up all those guys together to get our mean at the end of the day. And you're probably wondering, why is this so important? This is really important here if we want to figure out certain outcomes, or at least long-term outcomes, if we're to use a probability distribution, such as casino games or things of that nature. Probably wondering, well, wait a second, what do you mean by that? Well, take a look. Let's look at an example here. Okay. Okay. So let's take a good look at this one here. Let's look at number 19, okay? So number 19, as you see here, talks about Ichiro's famous baseball season in 2004. We got lots of hits. Anyway, I digress. What matters is that we have this probability distribution here. All right, so let's take a good look at that. So, number 19. In the 2004 baseball season, Ichiro Suzuki of the Seattle Mariners set the record for most hits in a season with a total of 262 hits. In the following probability distribution, the random variable x represents the number of hits Ichiro obtained in a game. So there we have it. 0, 1, 2, 3, 4, and 5. All right. Now, we're just going to kind of skip around here. We're going to do letter C. We're going to do letter, actually, E here first. Okay. So let's do letter E. Letter E says, what is the probability that in a randomly selected game, Ichiro got 2 hits? All right, so let's start off with something easy and work our way up. Put this over here on the left. Okay. All right, so let's go. I'm just going to start off with letter E because it's the easiest. What's the probability that Ichiro got 2 hits, according to our table? Anybody put that in the chat there? .2857 is correct. Very good. Let me make that a bit. Oh, it's not what I want. So yeah, make that a bit bigger for you guys. There we go. Hopefully that's a bit easier to read. All right, so .2857 is correct. Okay, very good. It is, Dylan. It is, my friend. How are you? Got the bag it. All right. Anyway, I like the way you work. All right. Anyway, I could digress here. All right. Let me ask some other questions here. What's the probability of really quick? You could end up with these questions here: 4 or 5 hits. What's the probability? Just grabbing some food, Nando's maybe, or are you going McDonald's? What's the probability that I wish I had some Nando's right now. Fair. Point some leftover bolognese from last night. Oof. I hope it tastes good after a day. 0.0621, and that's correct there, Vince. So we have the probability of 4 plus the probability of 5, since we have the probability of 4 or 5. Again, much the same way we've done before. So 0.0373 plus 0.0248. Alright, and that will indeed get you the answer, as Vince has there, of 0.06. Of course, when I cook it. 0.0621. Alright. How are we finding this on the calculator, Jasmine? Are you talking for the for these probabilities you see here? We're just following the table here straight up, Jasmine. So here's the table right here for number 19. We're just following the probability distribution. So here in this case, we're adding these two probabilities together. The probability of 4, which is 0.0373, and the probability of 5, which is 0.0248. No, it's okay. No worries. It happens. No sweat. Actually, I gotta get one chapter up. Alright, anyway. Alright. Let's try another one here. Now, let's try letter C. And we're gonna go through this here together. We'll do this by hand. A little out of it today, in all honesty. It's okay. It's okay. It's fine. I woke up late. I was a little late to the party. At least my mind was. Until I had some caffeinated beverage, I should say. That's fair. Alright, so we're going to do this 2 ways here. We're going to do letter C. Compute and interpret the mean of the random variable x. So we're going to talk about the mean / expected value here of this probability distribution. So the first thing I'm going to do is I'm going to do it by hand. And then in the next part here, when we talk about part D, finding the standard deviation, I'm going to talk about how we can do that via the calculator. So we're going to do it kind of both ways here, just to showcase finding the mean or / expected value with an already predetermined probability distribution is actually pretty fast to do, even by hand. So if I want to compute and interpret the mean here, all we have to do here is we're just going to find, in this case, let's find the mean. We're going to take the x that we have here, okay, so the probability again, the random variable, we're going to multiply it by its respective probability. So we're going to have, in this instance, we're going to have 0. So mean / expected value, same thing. We're going to have 0. Oops. How did I put that? Hang on a second, guys. Thought I put times here, but I put plus. So we're going to have 0 times 0.1677 plus 1 times its respective probability of 0.3354 plus 2 times its respective probability of 0.2857 Alright, plus 3 times 0.1491 plus 4 times 0.0373 and then plus 5 times 0.0248. Okay, there we go. And can anybody give me an answer here? What's the mean we get here in this case? Go to 4 decimal places just as usual. Anybody got an answer for me here? One 1.6273. Okay. .1184. Yeah, that's a little bit too low there, Vince. Remember, we're multiplying here and then adding each time down. We're not multiplying each one of these together, Vince. So that may be where things are going a little bit wrong. We're doing 0 times 0.1677 plus 1 times 0.3354. And then plus 2 times 0.2857. So, yeah, be careful about that. That's what it means, again, so we're doing here in this case. 1.6273, Joseph got that, okay. Okay, good. So in this case, what would that indicate in this instance? In this instance, that would indicate that the mean number of hits that Ichiro gets based on this probability distribution is 1.6273 hits a game, okay? I got 0.3754. What is the right way to do it? Well, I'm not sure how you got 0.3754. Again, you have to recognize that we're multiplying each one of these together. That's why I put parentheses around each of them. That we are multiplying each one of these guys. So if we're looking at the calculator here, go bring it up for you. I'll need this anyway, so now's not a bad time. So if you're doing this properly here, I'm not sure how you're doing it, so I'm not gonna, of course, I don't see obviously what you see on your calculator. But the way you would do this on the calculator here would be, you just put parentheses here, 0 times 0.1677, close parentheses, plus 1 times 0.3354. Just do it exactly like I have it on the screen there. 2 times 0.2857. What I got here? 3 times 0.1491. I'm not sure what you're entering in, but maybe you're accidentally entering in an extra 0 there, sneaky, and maybe that's what's going on. So, you got to be careful about that. What do we have? Yep, 1.6273 is the correct answer. There you go. All right. I was just entering it wrongly. Okay, that's fine. That happens. No problem, no problem. Okay, good. Okay, any other questions before I move forward? Okay, so the next thing I'm going to talk about here, and we're still going to continue here with this problem, but the next part of this problem here is letter D, and I'll go ahead and read that off here really quick. Letter D in this problem talks about how do we compute the standard deviation for this random variable. Now, the standard deviation is not something we're going to go ahead and find on our own by hand. Just like we did standard deviation, we found that using the calculator when we first talked about it back in chapter 3. So once again, we are going to basically use the calculator for that. And so let's go ahead and do that here in this instance. So I'm going to put this up here for right now. So the variance and standard deviation are going to work not the same as we talked about before. The formula here is significantly different. So as you can see here, we have the standard deviation, which is the rho x. The rho x squared is going to be your variance, so just like we had from before. Okay, now the formula here is significantly different. Notice I didn't really put anything associated with that here. The reason why I decided not to do that here, at least in this instance, is because we're not memorizing this part here. We're just going to want to actually apply it and then be able to find it. So we're going to go through this together here. You guys can mark this down for your notes, of course, as you see fit. But what we're going to do first is if we're going to find the standard deviation and the variance, we can find the standard deviation first via the calculator, and then we can square that result to get our variance at the very end. Okay, so if we need to do that, we'll be able to do that, no problem. Okay. All right, so I'm going to move from this point here, and we're going to go ahead and do problem 17 on the calculator for part D. So say goodbye to this dude for right now. If you need me to go back to that portion, I can a little bit later, but I want to focus on this for right now. Okay. Okay. So letter D, compute the standard deviation of the random variable x. Okay, so now in this instance here, we're going to do this via the calculator. So let's go ahead and find out what this is via the calculator. Let's see what we get. Let's bring up the calculator once again. All right. There's the calculator. Okay. Let's do this once again. Let's do the same thing we did last time. All right. So really quick, please type done in the chat if you have your calculator without and with you in front of you. Type done in the chat if you have your calculator out in front of you, so we know where to start. Just want to be sure everybody is on the up and up. Okay, so first things first, everybody, we're going to go ahead and I'm going to assume everybody else has the calculator here. We're going to hit the stat key here. We're going to go to edit. All right, I'm going to clear out these lists here first of all. These are lists, so clear and enter to highlight that top portion if you have numbers that exist already. Okay, now in list number 1 here, we're going to go ahead and put in all our x values. So first column, 0, 1, 2, 3, 4, and 5. Okay. And then list number 2 here, we're going to go ahead and put in all the probabilities appropriately like it is on the screen. Once you have all those values entered in, go ahead and type done in the chat once you went ahead and done so. Good, good. All right. Let's move forward then. All right. I'm going to assume that all you guys have this in. All right. So what we're going to do next is we're going to do the same thing that we did before. Okay. So let's go ahead and see what happens here in this case. All right. So double extra sure about that. I wanted to make double extra sure about that. All right. So we're going to hit second mode to quit to the main screen. We're going to go ahead and hit the stat key here once again. We're going to go to calc. All right. I'm going to go to number 1 here, which is 1 bar stats. All right. So just as before here, once we get to this menu, old school calculator, you're going to make it look like this. Once you hit enter on 1 bar stats, you're going to do L1, comma L2. For those of you who have this submenu here, go down to the frequency list here. List 1 should be L1. Frequency list here should be L2. So you hit second and 2 to have L2 show up as part of your frequency list. And then go down to calculate. And hit enter. And this is what you should see here on your screen. Please type done in the chat if you get these same exact numbers appear on your calculator. Comma key is right here above the 7 key, Sneaky. Right where my mouse is. Look above the 7 key, and that's where the comma key is. No problem. You're getting an error, okay? So if you're getting an error there, Joseph, go back to your list there. Make sure that you entered in the correct numbers in there, Joseph. Make sure that they're the same amount of numbers. You should have 6 numbers on the left and 6 numbers on the right. You should also make sure that you entered in these decimal numbers exactly as you see here on the screen, Joseph. All right. Oh, you got it? Okay. All right, that's fine. All right, good, good, good. Too many numbers, okay. I'll go back for a second. Go. Okay. So, let's take a look at what we can see here. Now, what we can see here is that we have a standard deviation here. And they're only going to give you one standard deviation for a probability distribution. That is here at 1.1785. So 1.1785 is going to be our standard deviation here for this particular problem. Okay, so I'm going to put here really quick 1 point. You may not be able to actually, maybe. I know I moved that over for just a second. So 1.1785 is going to be our standard deviation here for this particular problem. Now, I do want to point out one thing here really quickly. Sometimes in some questions they may ask you for the variance as well. Okay, so let's talk about that here. Now, we're not finding this by hand. We're finding this via the calculator. Now, if it does ask you for the variance here, the variance is basically taking the standard deviation and squaring it. That's all you're essentially doing. But what I would like you to do here in order to get the most accurate answer as possible, specifically in this case, is to take the full number here, take the full number of the standard deviation and then square it. So instead of taking 1.1785, which is like a rounding thing that we usually do for what we enter in for our final answer, for example, here, what I would like you to do is take the full decimal that you see there on the screen, so the 178471345, and I want you to go ahead and square that in this instance to get your variance. And only after that point, once you square it, then you could go ahead and round it to 4 decimal places after you square it, so you get the most accurate answer possible. That's what I'm going to do here in this instance. So remember, it always goes round at the end, but never in the middle. Okay. So in this case here, your variance here would be 1.3888. Okay, so because the reason why I can round here is because this is the end of the problem and not in the middle. Same with standard deviation, that was the end of the problem but not in the middle. So that's a common thing we're going to follow sometimes, is we don't want to round right in the middle, we want to round at the end. Let's put a note there. Any questions? Oh, you want to see the formula? Yes. Sure. Jasmine's like, I demand to see the formula. I need to see the formula. I have demands, darn it. Jasmine's like, help me, my OCD. Oh my goodness. I didn't get to see the formula. Anger. It's gonna overwhelm me. Man. I know. I know how to, if we're gonna do OCD moments here, I know how to use that to my favor. That's like what I used to do in like face-to-face classes. Like when I did face-to-face classes, what I would do sometimes is I'd just put a dot, like a marker dot on the board, and I would just leave it there for like 10 seconds. And then I would just be like scanning the room to see how many people are sweating bullets for me just putting a dot on the board. And I'm like, okay, I know, I know who's, OCD and who isn't. Like, okay, perfect. I'm like, you, you. Can't say I'm not cruel. I'm a math professor. Of course, I have to be cruel in my own right. The only correct thing to do. Um, that's just how it works. All right. Any questions? Any questions about that, guys? All right. We'll do one more problem here really quick. I'll show you where this can especially be useful. Okay. Let's take a good look here at let's look at 29 actually. That one's a little bit more abstract. All right. Let's look at 29. Roulette. Okay, roulette. The worst a casino can get, roulette. All right. In a game of roulette, a player can place a $5 bet on the number 17 and have a 1 out of 38 probability of winning. If the metal ball lands at 17, the player wins $175. Otherwise, the casino can take the player's $5. What is the expected value of the game to the player? The best casino game. No. It's, man, the best. You'll understand why this, Alex, this is the best casino game. Air quotes. This question is a very good question just for that. If you played the game 1,000 times, how much would you expect to lose? So even in this question already, you guys, they already say, how much do you expect to lose? So they know you're going to lose money, all right? Just 100%. The question is, how much will you expect to lose if you played 1,000 times? Okay, seems fair. Let's find out, shall we? And this one is not as bad as you may think. Takes a little setup. All right. So you can place a $5 bet here. So let's put in X here is a $5 bet. So we'll put X here. X is going to be our profit. And so that's going to be our profit there. Let me check that really quick. If they are going to consider it that way. Okay, that's fine. They're going to do it that way. That's okay. All right. So let's talk about profit here. We're going to profit We're going to profit one way, and we're not going to profit the other way. Okay. So let's say I lose. How much am I profiting, guys? How much if I bet $5? How much am I losing? What are the odds of me and also what are the odds of me losing? How much profit do I make if I lose in roulette? Let's answer that question. There's a 1 out of 38 chance of losing? I'm talking losing. 0. I don't get... No, guys. I don't gain anything. You're wrong. That means if I bet $5, I've lost effectively nothing. You're incorrect about that. How much did I actually gain? That's the trick. The trick is you're actually losing something out of the deal. If you talk about profit here, guys, you actually are losing $5. So your actual profit is -5. Think of it as a business instead of like an absolute. If you're a business, you could be in the red or in the black. You lose a game of roulette, you lose $5. -$5 in profit. Now, that's where you got to be a little careful about here. Now, what's the... Indeed. So what's the profit? What's the probability that you will lose in a game of roulette? What's the probability? What's the probability that you will lose in a game of roulette according to our scenario here? 37 out of 38, right? I agree. You say 37 out of 38. 37 out of 38, that's true. All right. Now, let's say we won. What's my profit if we won? What's our profit if we won? $175, that's correct. Now, normally I would agree with you, Alex. It'd be 170 because technically we include that $5 as being a part of our bet here. So, in reality, I would actually agree with you here. For the sake of this particular example, they're going to want to say that 175 is our profit. But I actually, in reality, would agree with you here, Alex. I actually would agree with you in this case. At least for the purposes of this problem. They don't actually explicitly state it, but 175 is going to be our profit here. It's just not very well worded. I'm going to be honest with you. So if you put 170, I'd be like, yeah, from what you see there, I'm not actually going to disagree. And we know we have a 1 out of 38 chance here in this case. Okay. Let's find our expected value. Let's find our expected value here. Our expected value here is going to be -5 times 37 out of 38 plus 175 times 1 out of 38. All right, let's do that on the calculator. Anybody tell me what we get here? In this particular instance, we're going to, yeah, let's go to 4 decimal places regardless. I'm just going to do that. I know we could probably do 2 decimal places, but what do we get here as our final result? -0.2632, okay? All right, that works. So, what happens in this case? What does this actually mean? That means on average, in the long haul, all right, if let's say, for example, here we have an infinite amount of cash. That means on average, every game, you are losing on average 26 cents per game, which is really, really awful. Okay, meaning to say you are already going to be guaranteed to lose 26 cents a game for every game that you play of roulette. Like, it doesn't matter. Like, it's that those are in the world of statistics, that is pretty gosh darn awful. This is why roulette is a really awful game. Now, that leads us to the second question that you see here. If you have played the game 1,000 times, how much would you expect to lose? Well, if we did play the game 1,000 times and we were expected to lose 26 cents per every game, all we need to do is take the we want to go ahead and take this 2.632. We'll multiply that by 1,000. Now, they probably would take you to say, okay, you know, you would do the first 2 decimal places for that. So for 1,000 plays, you're expected to lose like minus $263.20, or 260 minus 260 if we were to round it to 2 decimal places. Expected to lose. It's not pessimistic. You are guaranteed to pretty much lose in roulette. So, unless you get pretty lucky. So, the odds are so bad in roulette, it's not even funny. So, if you ever don't play roulette in a casino. It's just a bad idea. Like, if you're ever going to play 2 games in a casino, play blackjack and play poker. Those are probably the only 2 that you should probably play at a casino. Every other game is not worth your time. All right. Any questions about that? Any questions? All right. Do you guys want to take a break? Blackjack or slots? Slots is Why did I go to minus 260? So I would go to minus 260 because you can approximate this to minus 26 cents. That's why, Jasmine. So if you didn't round to 4 decimal places, if you rounded to 2 decimal places because we're talking about dollars and cents, then that's why we would take minus 260. That's why it would be fair. Slots are no bueno either. I mean, slots are RNG based, but yeah, I mean. Yes, please break. Okay, that's fine. Let's go to 12:15. Okay, and we'll be back at 12:15. We'll get started with a little bit of section 6.2. We'll see how far we get, but we're in good shape. So let's take a small break, guys. 12:15. We will be back.
Every day is giving up of our faith and live. Give me sleep, fade away. Fade away. Every day I feel time slipping, passing, skipping by. All the words I could say just can't really seem to stay.
Okay, and we are back. All right, let's get back to the second half of this class here. I know it'll be a short one, as we went a little over time there for the first half there. Now, we are going to be moving on here into section 6.2. So section 6.2 is what the next thing we're going to talk about here. So let's go to the big board here once again, and let's talk about this very next section that we are going to do here together. Now, of all the sections in the textbook here so far that we've covered up till this point, this section here will require you to read the problems very carefully. I'm just going to point that out here. We're going to talk about reading the problems here very carefully. So we talked about before early in the semester, we said, hey, wording matters, and how that actually affects probability. That is definitely something that we saw early on, like with at least, or one or more than one, or less than one, or at least, something like that. We've taken a look at several probabilities where wording absolutely mattered and absolutely did affect our final result. This section here is no different than what we have talked about before in the past in that regard. So what exactly are we doing here in this section for section 6.2? Let's talk about it right now. So what we're going to be doing here is we're going to be conducting a binomial distribution type of problem here. So let's talk about what a binomial distribution is and how it works and all that stuff. So determine if it's binomial, compute probabilities, and determine mean and standard deviation of binomial random variable. Now, we may not get to everything here today because we only have a limited amount of time. I think we got like 20 minutes or so. But I want to talk about at least the basics here and do a couple of examples, and then we'll do a few more examples for next time as well. All right, first of all, what's a binomial kind of a distribution? What does that mean? Well, binomial, as you know, bi, like binary, means two. Like binary means zeros and ones, right? So binomial means two. And this is important here to know that it means two. Why? Because in a binomial distribution, we are either going to have one of two choices that it could fall underneath. Either, for example, it could be the statement we could make here could be true or false, or it could be one state or another state. Maybe we only have between two different choices that we can have here. So unlike a probability distribution where you can have multiple outcomes, we're only going to have two possible outcomes here. Either, say, the true outcome or the false outcome, for example. Okay, so that's one thing that we have to take to the bank here. The second thing is that because we're going to have a probability, we're also going to have a probability here associated with each one of those outcomes. So if we say have a true outcome and a false outcome, hey Yusuf, how are you doing, my friend? Then we're going to have a probability associated with a true outcome, and we're going to have that, and we're going to have a probability associated with a false outcome. Now remember though, very important here, true and false do not necessarily have the same probability. So it's not going to be like a 50%, 50%. It could be 70% true and 30% false, for all you know. That's all you know. All right, so there you go. So what is the formula here for a binomial distribution? Let's take a look at the formula here. Let's talk about it. So the probability of R, now we'll talk about what R means, is equal to NCR. That is exactly the number of combinations. Choose R. With P being the probability of success to the R power. R is going to be the number of successes times the probability of failures, which is 1 minus P. That's the probability of a failure, to the N minus R power, which is the number of failures. So R here is the number of successes. So how many succeed? Okay. P is the probability of success out of how many a number of trials that we do. As we like to say here, let's talk about it in terms of not just true or false. Let's talk it in terms of success and failure. Okay? How many succeed and how many fail. Okay, P is the probability of success. 1 minus P is the probability of failure. Okay, so again, just two states that are probably easy to work with. Success and failure. Yes, great win last Sunday. I agree. I watched that whole game. It was great. We had a really good squad going into Sunday. They really showed up. Now, the second key here I want to talk about is wording. Wording is going to be incredibly important, as I've already prefaced earlier. What do I mean by wording is going to be incredibly important? Well, we are definitely going to use our calculator for this, because I want you to take a look at this formula here. If you're going to use this formula that you see up here on the top of the page, wow, that's a pretty long formula. All right, and by no means do I actually want to type that out on the calculator every single time I want to do a problem. That's just crazy. All right, so we are going to use the calculator here in order to, shorten this down. However, there is one caveat that I do need to discuss, and this is why wording is incredibly important. It's because the function on your calculator that talks about binomials, and by binomial distribution specifically, is limited in capacity. Okay, so your calculator is limited on what it can and cannot do, and we need to be very specific about what it can do so we know to enter in the right numbers depending on the circumstance and problem that we're given here. Let me go ahead and demonstrate what we see down here. So this part here, I am going to give you a little time to write this down, because this, if there's anything you need to write down, it's this part right here for the calculator portion. Absolutely have this as a nice little handy reference because you need to know exactly what these functions are, and I'm going to show you where it is on the calculator here once we do an example here in a few minutes. Okay, so first and foremost here, we're going to use there's only two functions on the calculator. All right, let's discuss both of those first and foremost. The first function on the calculator is the Binomial Pdf function. Now, Binomial Pdf, if you're using the old school calculator and you want to know the formatting for that, that's going to be the number of trials, comma, the probability of success, comma, and then the number of successes. Okay, so the number of trials, followed by the probability of success, followed by the number of successes. We'll actually see this here in the calculator. If you have the new school calculator, then you'll see this already broken down for you once we take a look at that. However, the one thing I do want to point out, and what Binomial Pdf represents, is that Binomial Pdf here represents exactly that number of successes. And I do point out the word exactly here. As I said here, wording is incredibly important. So, if I'm talking about exactly 5 successes in this random probability trial, I'm going to use Binomial Pdf. Okay, if that's what it says in the problem. All right. So that's the first one there. Now the second one is going to be Binomial Cdf. So we have Binomial Cdf here. Binomial Cdf, the formatting here, if you have the old school calculator, is exactly the same. The number of trials, followed by the probability of success, followed by the number of successes. However, Binomial Cdf is a different meaning. Binomial Cdf here means that it's going to be, because of the limited scope of what you can do on a calculator, Binomial Cdf means that you are less than or equal to that number of successes. So note, less than or equal to is what Binomial Cdf is going to represent. What that means is that we're going to have to work around this limitation because of what is in the calculator and what we can and cannot do. So we're going to be working around this limitation here of less than or equal to in order to solve for other probabilities. So I'm just putting this out there now. This is why wording here is very, very important for this section. Now that we have a preface about what each of these things look like, we need to take a look at a problem here. Okay, let's work on it. We're going to work on just maybe an example or two here today, and we're going to look at some more examples using these functions here, so this definitely won't be the last time. We can spread it out over 2 days and we'll be okay. So let's at least take a look at the book here. By the way, before I move forward, are there any questions so far? No? Okay. So, let's go through this carefully. We're going to go over this very slow, okay? Maybe I may just get through one example here today, but I want to go over this slow so that way everybody is on board. We know what we're doing here, okay? So the problem I'm going to do here is number 35 to start with. Let's look at 35. So 35 here, this is from section 6.2. On-time flights. According to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. Suppose 15 flights are randomly selected and the number of on-time flights is recorded. Okay, we're going to do 3 of these probabilities here. Let's look at, actually, we could end up doing all 4 of them. So let's look at letter B. Find and interpret the probability that exactly 10 flights are on time. Now, before we go ahead and get started here, let's at least make note of a couple things. Number 1, what's our number of trials here? Our number of trials here is going to be 15. They selected 15. Again, 15 flights need to be are selected here for this random study. What is the probability for success? What's our P here, guys? Can anybody tell me what's our P? What's our probability for success in this case? All right, 80% as in, give me a decimal, guys. We need a decimal for this. We're going to be using decimals. So 80% is true. What's 80% as a decimal? 0.8. Good. We're going to use, I'll put in for the sake of some people, we'll put 0.80. Okay, so 0.8, 0.80, either way. Same thing. Okay, good. So notice we have, again, we need to establish this right away. First of all, how many flights are we studying over? We're studying 15 flights. What's our probability of success? 80%. Fair. Okay, now if we look at letter B here, we are now doing the probability of exactly 10 flights arriving on time. Okay, now, if we look at the exactly 10 here, all right, let's go back to our guy for just a moment. What function on the calculator are we going to use? Are we going to use Binomial Pdf or are we going to use Binomial Cdf? Are you going to use Binomial Pdf or Cdf here to find this particular probability? Okay, that's correct. All right, so let's talk about what numbers we're going to put in to Binomial Pdf. So we can write this out, and then we'll see. Well, we're going to do it on the calculator, of course, but just for the sake of, again, knowing what you can write down on a piece of paper so you can keep your thoughts organized and collected. So we can have Binomial Pdf. Now, just taking a look here, we start off with the number of trials. Now, the number of trials is your n. So that's going to be 15. So we start off with 15 here. Our probability of success, we said, okay, probability of success here is 0.8. 0.8. Okay? And exactly the number of successes here, since it's exactly 10, we're going to put 10, just like so. I want to point out something here. Very important. Okay? The first number here should always be bigger than the last number. Okay? Put that here. I'm going to put that as a note in the chat. The first number should always be bigger than the last number. One of the biggest mistakes people make when doing this on the calculator is they forget which number needs to go where. Remember to note that the number of trials goes first and the number of successes goes last. Again, I also put this note here just to be on the safe side, that you know that whatever number goes in front, the first number always needs to be bigger than the number that goes last. 100%. Okay. Because what happens if you reverse the numbers, you get 0, and then you're sad. You get 1, and then you're sad. All right. Okay, so how do we do this on the calculator? Let's talk about that. All right, so we need to talk about the calculator here. All right. So what we're going to do first, all right, what we're going to do first here is we are going to go ahead in this case here. We're at our main screen here, so you have your calculator in front of you. We're going to hit the second key, and we're going to hit the vars key. So we're going to hit the second key and the vars key. Okay. Let me put this in chat here. So the second key and the vars key here. Okay, so you should see this menu like you see on the screen, just like so. Now, what I would like you to do here is to scroll up, and that will just wrap it around. And I want you to take a look at these two options we see here. We see letter A, which says Binomial Pdf, and we have B, which says Binomial Cdf. In this case, for our purposes of our example, because we want exact, we're going to select letter A, which says Binomial Pdf. Okay. Now, if you have the old school calculator here, I want you to enter in these numbers that you see here on the screen right below my face. All right? If you have the new school calculator, and if I hit Binomial Pdf here, this is what you are going to see here on the screen. And all we want to do here is enter in the exact numbers you see here on the screen right below my face, the 15.80. Again, that's going to be P, your probability of success, and your X value, the number of successes, which will be 10 there appropriately. And then just go down to paste and hit enter. So this is what you should see here so far. And then go ahead and hit enter one more time. And this will be our final answer for our problem here. In this instance, 0.1032. Okay, please type done in the chat if you got this exact answer. Hopefully everybody got that. Okay. Any questions so far? Everybody got that? Everybody's good. Hopefully everybody's good with that. Okay. So Binomial Pdf isn't too hard. Again, it's just like a one and done sort of thing. It's pretty easy. Okay. Now, let's go to the next part here. I just have a few minutes, so bear with me. So, letter C says, find and interpret the probability that fewer than 10 flights are on time. Probability that fewer than 10 flights are on time. Okay. So, you guys tell me, which one am I going to use? Am I going to use Binomial Pdf or Binomial Cdf in this for this particular example? Okay. Okay. CDF is perfect. All right. No problem. All right. Now, why don't you guys tell me, what numbers am I going to use underneath this premise? I want to find the probability of fewer than 10. What numbers am I going to plug into Binomial CDF here in this instance? What number should I use? $15.8 and 10. Okay. Everybody good with that? 15.8 and 10. All right. Good. That's incorrect. All right. I had to lull you guys. Remember, as I pointed out here, wording is incredibly important. Look at it very carefully. I'm not doing point 2, not in this case. I'm only going to be looking at probability of success here, Joseph. So, now Joseph, I like that idea. That idea, my friend, is a lot better. This is true. So we still have the same number of trials, true. Same probability of success, that's still true, 0.8, 100%. However, look carefully, just as Joseph pointed out here. Remember, we have fewer than 10. It doesn't mean 10 or fewer. Fewer than 10 and 10 or fewer are two different things. Okay? The wording here means a lot, guys, and you need to be very careful about that. So we actually are going to put 9 here instead. Remember, Binomial Cdf means less than or equal to. Less than or equal to 9 is the same as fewer than 10. Those are the same actual things. Written differently, you betcha. But they actually have the same meaning. You betcha. This is where things start to, it starts to ratchet up a little bit, be like, oh boy. Yeah, wording is definitely a thing. Now, we're going to do this on the calculator together here. This may be the last example that I can do since I'm running out of time. Alright, now for us to do that here, let's do it together. We're going to hit the second key and the bars key here once again. We're going to go up here to Binomial Cdf. Again, if you have the old school calculator, again, enter in exactly what you see there at the bottom of my side of the screen with my face on it. Otherwise, do the same thing, and I think most of you have got this. 15.80 and 9 here. Paste that in. And you guys are absolutely right, 0.0611. Okay. All right. Any questions about that? Nice job, Jasmine and Melissa. Any questions about that? You'll notice, I know I've ran out of time here to do this. I'm going to be doing this question here. I'll start with this question here on Thursday, guys. And we're going to do the last couple parts here that I do want to actually talk about. Because there are a couple more questions that we do need to kind of get used to. But again, I want you to make note of the wording here. The wording here for this problem here is incredibly important. So again, please be very careful. What homework should we do before Thursday? That's fair. Up to 6.1. Up to 6.1. Yeah, sure, Jasmine. Up to 6.1 is probably where I would like you to be. High maintenance. So high maintenance that I need a pinky for this. Yeah, so I don't want you to work on 6.2 just yet because I want to talk more about 6.2 and I want you to get comfortable with the idea of the wording behind 6.2. So I don't want you to attempt that just yet if you're working with the pace of the class. Thursday, after that, you can work on section 6.2, but I need to clarify a few more things about how to attack some problems. Yeah, so until 6.1 here, yeah. I'm not comfortable I'm not comfortable just yet from where you are at for 6.2 because there's a few more problems that you need to tackle and you probably would easily get lost if you're not very careful. So we're going to look at those problems here for next time. and we're gonna get those out of the way as well. Okay, but up to 6-1 here, we'll be just fine. There's only 2 sections in chapter 6 anyway, so we're in good shape nonetheless. But wording, man, wording in this section here is so important. I ain't gonna lie. Just one of those really, really tricky things. Any other questions? Any other questions? All right. If there are no more questions here, I want to thank everybody who has come out to the stream once again. All of you are absolutely fantastic people. All right, I love all of you. All of you will make this class absolutely great. Thank you so very much, everybody. We're gonna come back here same time on Thursday. Okay, everyone have a wonderful afternoon and evening, and I will see you in a couple of days. All right. If you guys have any questions or like to talk, you guys know exactly where to find me. I'm on Discord or again on the email. Please feel free to contact me, and I'll be more than happy to get back to you ASAP. All right. Have a great day, everybody, and we will see you all later. All right. Have a great one. See you later. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane. All right. Have a great one. Thank you. Thank you, Jasmine. Thank you, Joseph. Thank you, Alyssa. Thank you, Sneaky Weasel. Thank you, Vince. All right. Thank you, Alex. Thank you, everyone. Thank you very much, everybody. All right. Have a great one. Take it easy. See you later, everybody. All right. Bye. Bye, everybody.